Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. And today, the topic has been mentioned in a startup video. Please watch it, the video, and then I'll start the questions.
Another one.
MC Ireland. I love geometry. Square the leg A and then square the V. Add these squares up equal to square C. Pythagorean theorem like a mathlete. Hypotenuse, what you call it? Long side, let's draw it. To get a fail, you can't afford it. Pythagorean theorem is important. Give me the A and B so I can find C. Check out the right triangle with the 4, 3. Square these numbers up like a mathlete. Add them up, slow down, it's not a track meet. Square root each side, don't be mad at me. Triple 3, 4, 5, that's Pythagorean. 6, 8, 10 like a triple team. Triple, get about the 5, 12, 13. So many triples you can fill up the whole screen. Let me show you another problem that you've never seen. Follow all the steps, please don't try to daydream. It's not a triple going round it if it isn't clean. I love geometry. Square the leg A and then square the V. Add these squares up equal to square C. Pythagorean theorem like a mathlete. Hypotenuse, what you call it? Long side, let's draw it. To get a fail, you can't afford it. Pythagorean theorem is important. Now let's analyze a problem where you're given C. And the mission is for you to find the A or B. You already know the steps, it's not a mystery. The only difference is in the subtraction property. Square root, each side, this is a trickery. 6.7, that's what it's supposed to be. Every single day we see making math history. Let's finish up with the converse and inequalities. You'll be given 3 numbers, so substitute these. Put them in, C squared is greater, and our case is a figure. If C squared is less, then a cube is the best. If the C squared is equal, then you know the rest. I love geometry. Square the leg A and then square the V. Add these squares up equal to square C. Pythagorean theorem like a mathlete. Hypotenuse, what you call it? Long side, let's draw it. To get a fail, you can't afford it. Pythagorean theorem is important.
Okay, students, I hope you have enjoyed the video. And the first question is from exercise 10B. And this exercise is about the word problem. So some questions which I will solve today is about diagrams. I have chosen some questions from the diagrams. So the first question which is displayed in front of you, that is about a ladder. And in this picture you can see that the ladder length is first of all, I have to write down the theorem. The theorem says that hypotenuse square is equal to base square plus perpendicular square. Because I have taught you all the questions about from exercise 10A, and you have learned about the basic questions about Pythagoras theorem. So this theorem is like this. The equation stands: hypotenuse square is equal to base square plus perpendicular square, right? So the picture which is in front of you, in this picture we have a ladder, and that ladder has a length of 6 meters, and the ladder reaches to the height of the wall, and the base is 1 meter. So the distance between the base of the ladder and the foot of the wall is 1 meter. So if I solve this question, like the hypotenuse, this is the question. This is, I can draw the diagram. This is the ladder. This is 1 meter. This is 6, and you have to find out the height of the wall, right? So there is a negative B angle. In front of negative B, we have hypotenuse, that is 6 meters, and base is 1 meter. Perpendicular, we have to find out, that is the height of the wall. The square of 6 is 36. The square of 1 is 1, and then we have to subtract these two values. 35. In the last step, you have to find out, you have to take the square root on both sides, and the answer will be 5.9. 5.9. Okay. This is a very simple question and a basic question about word problem. Uh, Next, move to the second question. Question number 6 from exercise 10B. Okay, you can see this question from the book. In this question, practical based questions, we have two vertical buildings. One building is 30 meters high and the second building is 37 meters high. And they have the distance of 16 meters, right? And a cable is attached from the top of the taller building to the top of the shorter building, right? This is the cable, right? We have to find out the length of this cable. So in this whole question, ultimately we have to draw a right angle triangle. If we draw an imaginary line here, this line is 16 meters because this is a rectangle. And a rectangle has opposite sides same. So if this is 16, this is the distance between the two buildings. This should also be 16, right? And if this is 30 meters, this should also be 30 meters. So the height of the taller building is 37 meters, right? So if we subtract the 37 minus 30, we will get 7 meters, which is the height of this triangle. It would be the height of the triangle, right? So now we have the given values in the triangle triangle. 16 meters is the base, 7 meters is the height of the triangle. We have to find out the length of the cable, and the length of the cable is the hypotenuse, which is directly opposite to the 90-degree angle. So if we look at the theorem, hypotenuse square is equal to base square plus perpendicular square. Hypotenuse is, we have to find out, base is 16, perpendicular is 7. So the square of 16 is 256. And the square of 7 is 49. If we add up these two values from the calculator, you will get 305. In the last step, in every question, you have to take square root on both sides because we have to remove the square on each. So when you take square root of 305, it will be 17.5. So the length of the cable is 17.5 meters. Right? So this is a very practical question. I hope you have understood this question. The question number 9 I have chosen from the exercise 10B. Right? So this question is a bit complex question, and I'm going to read this question from the book. Two spotlights P and Q are mounted on a vertical pole AB. Light beams from P and Q shine to 2 points on the ground H and K respectively. Given that PQ is 12.7 meters, KB is 17.2 meters, PH is 39 meters, and QK is 21 meters. What we have to find out, all the things out the diagram I have drawn on the board, in front of you everything is labeled, but what we have to find out, BQ. What is BQ? Actually, BQ is the height. On point P and Q, we have two spotlights, right? And that spotlights are falling the light beams on the level ground at 2 points H and K. The light beam from spotlight P is falling on H, and the light beam of spotlight Q is falling on K point, right? So we have to find out BQ. What is BQ? BQ is the height at which the spotlight Q is mounted, right? So you can see that in this whole diagram, it is a composite diagram because in this diagram we have two right angle triangles. and the perpendicular is same, the common line. Uh, if I take this triangle out, the smaller triangle, in this triangle we have KB 17.2, this is Q, QK is 21, this is BQ, this is BQ. I had told you that if we have to find out the side of any right angle triangle, we should have two sides given. And in this triangle, in this shorter triangle, I have two sides given, QK is 21 and KB is 17.2 meters. So, in front of 90-degree angle, 21 is the hypotenuse and KB is the base. You have to find out the BQ, which is the height of the triangle. So apply the theorem, hypotenuse square is equal to base square plus perpendicular square, right? So hypotenuse is 21, base is 17.2, we have to find out P. If scale of 21 is 441, the scale of 17.2 is, if we just find out from the calculator, 17.2 is 295.8. So we have to subtract 440, we have to subtract these two values, move this to the left side, 295.8. Subtract these two values, 441 minus 295.8. That is 145.2. 145.2. Now take the square root on both sides because in every question in the last step you have to do this thing, because do not forget this thing, because we have to remove the square on the variable. So if you take square root of 145.2, it will get 12.04, 12.05. 12.05. This is the P. And what is this? This is the BQ, means the height of the triangle, means the height at which the spotlight Q is mounted from the ground. This is BQ. The second thing which we have to find out in this question is HK. Now what is HK? HK is the distance between the two light projections, right? Means the light beam of spotlight P is falling on H and the light beam of spotlight Q is falling on K. These 2 points are on the ground. So we have to find out the distance between these 2 points, right? So what we have to do now? We have to take the larger triangle, the main triangle. If I draw this triangle separately, P, B, and H. P, B, H, yes. Now, we have the hypotenuse is 39. 21 was the hypotenuse of smaller triangle, but 39 is the hypotenuse of the larger triangle. See this thing very carefully. This is the 39, which is the hypotenuse of bigger triangle because it is in front of the angle. Now, what is the height? Height we have to find out ourselves because in the first part we have found out BQ, that is 12.05, and PQ is given in the question, that is 12.7. Add up these two values. Add up these two values. 12.7 plus 12.05. This is 24.8. 24.8 is a total perpendicular. Now, first, for finding HK, we have to find out the main base. We have to find out the bigger base, that is HB. First of all, finding this thing. Apply the theorem again in this triangle. 39 is the hypotenuse, HB is the base, and 24.8 24.8 is the perpendicular, right? Now, the square of 39 is 1521. The square of 24.8 is 24.8, that is 615.04, right? Subtract 1521 minus 615.04. 1521, that is 905.96. In the last step, again, you have to take square root. (905.96). That is 30.1. 30.1 is the total base meters. This is 30.1. Okay? This is 30.1. Now, if we have to find out HK, we have to subtract 17.2 from 30.1. Here, I will solve. HK is 30.1 minus 17.2. 30.1 minus 17.2. 17.2. That is 12.9. This is the distance between the two light projections. So, I hope that you have understood this question. A bit bigger question, but we have to solve it. So one more question, I'm going to do this because in this lecture I'm going to finish this exercise 10b. In the next lecture, there will be 10c, which is the last exercise of Pythagoras theorem. In these two lectures, in these two lectures of the upcoming week, we will finish this chapter, inshallah. So one more question I'm going to solve. Then I'm going to attach a worksheet to this lecture, and you have to do that worksheet because it will create a better understanding for, among you, because that will be the homework for you. So the first question I'm going to raise, the question 8. Question 8, right? From exercise 10b, I'm going to read question number 8. A table coaster in the shape of a rhombus has diagonals of length 10 centimeters and 24 centimeters. Find the length of each side of the coaster. So, a table coaster is in the form of rhombus. So, you know the properties of rhombus, like this is like square, like in square, all the sides of square are same. Same in rhombus, all the sides of rhombus are same. But it is a tilt form of sphere. In the sphere, we have 4 90-degree angles, but in rhombus, we do not have 4 90-degree angles. This is the rhombus shape, and a table coaster, which is written in the question, is in the form of rhombus, has diagonals of length 10 and 24. And I have told you the concept of diagonal in the quadrilateral. Diagonal is the line which joins the opposite corners of a quadrilateral. Like this is the diagonal of first diagonal, and this is the second diagonal. Okay? So these two are the diagonals which join the opposite corners. So I am going to revise some properties of rhombus in front of you. Rhombus has four equal sides, like I can write x, 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 right? Uh, when we draw the two diagonals, of a rhombus, the diagonals will be divided into two equal parts. If this is 10 centimeters, it would be 5, 5. If this is 12 centimeters, 24 centimeters, this is 12, this is 12, right? Again, I'm going to repeat. If this diagonal is 10 centimeters, right? When we draw two diagonals, because of this point of intersection, this diagonal will be divided into two equal parts, 5, 5. This is 24 centimeters. It will be in two equal parts, 12, 12. One thing. The second property is that in the rhombus, at point of intersection, we have four 90-degree angles. Again, I'm going to repeat. In the rhombus, when we draw two diagonals, at point of intersection, we have four 90-degree angles, like this. It means in rhombus, we have four right angle triangles. We have four right angle triangles. So it means you can take any right angle triangle, because you can see in every right angle triangle we have same sides, 12, 5, 5, 12, 12, 5, 5, 12. So all the right angle triangles are same, right? So you can take any triangle, this one, this one, this one, this one, because we have to find out the length of the side of the rhombus. We have to find x. So you can take any triangle. If you can take this triangle, this is, we have to find out x, because what is x? X is the hypotenuse. X is the hypotenuse because it is directly opposite to the 90-degree angle. So